This is a really simple circuit, just 3 resistors in series supplied by 15.7 volts, 68 ohm resistor, 56 ohm resistor and a 47 ohm resistor. And the deal is that we're going to take some measurements such as measure the power supply voltage, log that down, and then we know what the total resistance is at 171 ohms. Then we'll work out the current and we'll go ahead and we'll work out the voltages. The voltages work out to 6.25 volts, 5.15 volts and 4.32 volts. You can see on the meter readings here in the video that the voltages across each resistor are pretty well identical to the calculations that we already performed. Then in the next part of the practical or the demonstration here, we go ahead and we look at the power being dissipated by each resistor. We use the equation V squared divided by R, and that would be 6.25 volts squared, for example, divided by 68 ohms for VR, in the first resistor there, R1. That would give me 574 milliwatts. Of course, the resistors we're using are only quarter watt resistors, and they're going to have their power dissipation exceeded quite dramatically. I've used a FLIR thermal imaging camera, and I've taken a photograph of the breadboard setup. Quite amazing that the individual resistors are getting very hot, but it appears from the thermal imaging photography that the points of contact are getting quite hot as well, as there would be some resistance in those particular joints on the breadboard. Of course, putting the finger across each resistor as well, they are quite warm, but amazingly the quarter watt resistors are performing quite well with twice the amount of power being dissipated by each one.